if we look at a tangent example, we can tell just based on the formula up here that tangent's going to be more complicated because there's more pieces to it. But it doesn't change our general approach. We're still looking for an exact value, which means special triangle. I still have a value in here, which is not exact. So I'm going to have to set it up as a sum or difference. I have tangent of negative 15. Now I could use even or odd identities in order to take that negative sign and do something with it, depending if it's even or odd, but I just want to complete the whole problem with the negative 15 in there. So the key is to write negative 15 as a sum or difference of two special angles. So in this case, I'm going to write it as 30 minus 45. So my first value is 30, my second value is 45, so x in this case is 30, y is 45. So I just set up the formula and I work through. I have in my numerator tangent of first, which is 30, and then since I'm dealing with a minus here, I have to do minus up top and plus on the bottom. So I get minus tangent of 45 all over 1, it's just part of the formula, plus tangent of first, which is 30, times tangent of second, which is 45. And I know all of these values. I can find the tangent of 45 and the tangent of 30 just based on my special triangles. So if I go through and start filling these place values in, again based on the special triangles, I have tangent of 30. Tangent of 30 is opposite over adjacent and rationalize. So I get root 3 over 3 minus tangent of 45, which is 1 over 1. And this is all over 1 plus tangent 30, which I just found is root 3 over 3, times 1, which is 1. That really does nothing for me. And at this point, it's the algebra that gets tricky. If we remember, when I go to simplify lots of fractions inside of fractions, my goal was to make everybody have the same denominator. In this case, my denominator I'm looking at is 3, right there. If I can make everybody over 3, then I can just cross out the 3's. So I'm going to take this side and multiply them by 3 over 3. This side here is going to be 3 over 3 times that 1. And here I have root 3 over 3 already, right there, times 1. And I don't need to add it to that 1 because he's already part of this multiplication. He's technically over 3 also. So let me rewrite what I have. I have root 3 over 3 minus 3 over 3 all over 3 over 3 plus root 3 over 3. And the key thing is, if everybody's over 3, I can go ahead and eliminate those. And that's going to give me an answer of root 3 minus 3 all over 3 plus root 3. A little simplifying makes it easier if I put everybody over 3. And there's nothing more I could do. I could rationalize that if I want to, multiply top and bottom by 3 minus root 3, but I'm just going to leave it the way it is. So I'm going to say that the tangent of negative 15 degrees equals root 3 minus 3 over 3 plus root 3. Again, I could rationalize him more, but I'm not going to. I'm just going to leave him the way that he is. Example of working backwards. Working backwards. This is really just a matching game. It says simplify using an identity. So I have to just choose which one to use. So if I look down here, I have to look for the distinctive features of what I'm given. If you notice here, I'm given cosine, cosine, sine, sine. I look at the order that these things come in. So if my first one I check is sine, this one goes sine, cosine, cosine, sine, which doesn't match what I had. I have pairs, cosines together, sines together. Obviously it's not tangent because there's no tangents. So I'm really looking at this guy right here. I'm given the right-hand side of my identity or my formula, and I have to work backwards to the left. So what I really need to look at then is that middle sign right there. He's plus. If he's plus, that means I'm dealing with plus right there, which was the bottom one, so I'm dealing with minus right there. So I really have the cosine of something minus something. The last thing I do then is match it up. The first place in my formula comes from the first place in the cosine, which was 34, and the second place, the y and the y match up, so that's 13. So if I simplify this just a little more, I get the cosine of 21 degrees. So if I did all of that stuff in blue and got my decimal value, or if I took the cosine of 21 degrees and got the decimal value, those two things would be exactly the same. Notice how I'm not finding any exact values here because I don't have any special triangles. Okay? So, going backwards, just match up the distinctive features of what you have. One more example. This is a really important example, and I'm going to go ahead and just stop this video here, and we'll do one video of just this example so I can explain it fully.